So we start exercise 3.2. Question number 1 to 5. Question 1 to 5. We are asked to find values of trigonometric functions. Values of trigonometric functions. Trigo functions. The first question, you are given cos x equals to minus 1 by 2, and this arc length, that is x lies in the third quadrant, so x belongs to third quadrant. This is given to you. So in the other language you can write, third quadrant is somewhere here. This third quadrant. Here pi, here 3 pi by 2. So you can say that x is, if I write in the other language, x is from pi to 3 pi by 2. This is what the meaning of arc length. Okay, now we want values of all remaining trigonometric functions. What I'll do, as you were doing in 10th standard, I'll use right angle triangle. I'll call this as angle x. Forget about minus sign right now. 1 by 2. Cosine is adjacent upon hypotenuse. So this is 2. So you can find this much by right angle triangle. So this is root of 4 minus 1, which is root 3. Okay, now we'll write the other values from this right angle triangle. So if I write sine x here, you know sine x is opposite upon hypotenuse, which is root 3 by 2. Once you know sine, you can write tan very easily because tan is ratio of these two. So tan x equals to opposite upon adjacent, ratio of these two, which is root 3. Once you know tan, you can write the cot. Cot x equals to, again, reciprocal of this, 1 by root 3. If you know sine, you can write cosec x. What's a cosec x? Reciprocal of this, 2 by root 3. And once you have cos, you can write sec x, which is nothing but the minus 2, reciprocal of this. These are just values. Now whether this is plus or minus, we decide based on the quadrant. Now pi to 3 pi by 2, third quadrant. If you recall all STC rule, all STC. In third quadrant, tan and cot both are positive, remaining all are negative. So this has to be negative, this has to be negative, this is already negative. These two are positive, remember. How I decided the sign? The sign you will not get by right angle triangle. That you have to see the quadrant, that all STC rule. T means third quadrant, you have T. T means tan and cot are positive. So these two are positive, remaining all are negative. So I have placed here minus sign, remember. Or without right angle triangle, you can do this way also, whichever way you like. I'll start with cos x here. You are given this, whichever way you like. I'm doing this way also. So cos x equals to minus 1 by 2. So you can use this identity. Sine square x equals to 1 minus cos square x. So you have 1 minus, if I put the value 1 by 4, so this is 3 by 4, sine square x equals to 3 by 4. So sine x equals to, when you take the square root, you must have plus or minus root 3 by 2, remember. Now here you cannot keep both because your arc length is fixed, x is fixed. It is in which quadrant? Third quadrant. In third quadrant, sine is negative. So you have just minus root 3 by 2. Remember. Not plus. Why this minus? Because x is in which quadrant? Third quadrant. The third quadrant, tan and cot both are positive, remaining all are negative. So here I did by right angle triangle. Sine I have decided using this concept, all STC concept. Sine x is minus root 3 by 2, remember. Now once you have cos, you have sine, so you can get the other value using these two only. So therefore what is tan x? Ratio of these two, minus minus will get cancelled, which is root 3. Tan x is root 3. Okay. What about cot? That's the reciprocal of this. It's a reciprocal of this. That is 1 upon root 3. What is cosec? That's the reciprocal of sin x. So cos x equals to minus 2 by root 3. What is next finally sec x? That's the reciprocal of cos, which is minus 2. So this way you can get the values of the remaining 5 trigonometric functions. I've shown both right angle triangle and directly using identity. What is important thing is here about, remember, plus or minus, and which is purely depends on, now remember, arc length. So be careful about what's the condition about arc length. Okay. Let's go to second question now. Here you are given sin x equals to 3 by 5, x in second quadrant. Second quadrant means pi by 2 to pi. This is the second quadrant. So you can say in the other language x is from pi by 2 to pi. Now recall these also, all S, T, C. So in the second quadrant, sine and cosec are positive, remaining all are negative. Let me use right angle triangle here. You can use identity also. Now if I call this as angle x, then sine is nothing but, opposite upon hypotenuse. Opposite upon hypotenuse. So what about this adjacent side? That is root of 25 minus 9. So 16. So this become 4. Now I'll write the other values. So what is cos x from this? Cos x would be 4 by 5. Adjacent upon hypotenuse. You know sine cos, so you can write tan x. What's the tan x? That is this upon this, opposite upon adjacent. You know cos, therefore you can write sec, which is 5 by 4. You know tan, therefore you can write cot, which is reciprocal, 4 by 3. And you know sine, therefore you can write cosec. So cosec x equals to 5 by 3. These are just values. How do we decide whether plus or minus? Using right angle triangle, you cannot decide plus or minus. That is the sign of the trigonometric function. Sign will be based on all STC concept. Here x is in the second quadrant. Their sine and cosec, these two are positive, remaining all are negative. So here minus, here minus, here minus, here minus. These two are positive. Sine and its reciprocal. Remember that sine and its reciprocal, that is cosec. These two are positive, remaining all. So here minus, minus, minus and minus. These four values are negative. I have used right angle triangle. You can use directly identity and you can get the values here. If I go to next question here. Next question, let me see that. I'll go to question number 3, third one. There you are given cot x equals to 3 by 4 and x is in third quadrant. X belongs to third quadrant. This is given to you, quadrant 3. As you know, quadrant 3 means pi to 3 pi by 2. This quadrant, third quadrant. Okay, if I use, you know cot x, therefore you can write tan x directly. What's a tan x? That's 4 by 3. In third quadrant, again you recall all STC. So tan and cot both are positive. So these two will be positive. Cot positive, tan positive. Remaining all are negative. Now if I use right angle triangle here, this is 4, opposite upon adjacent 3. So hypotenuse would be root 16 plus 9 will be 5. This is 5. I'll write other trigonometric functions. Let me write sin x here, opposite upon hypotenuse, 4 by 5, but it is negative. If I write cos x here, adjacent upon hypotenuse, minus 3 by 5. Why minus sign? Third quadrant, cos and sin both are positive. Only tan and cot are positive. You know sine, therefore you can write cosec. What's cosec? Minus 5 by 4, reciprocal. What is sec x? Minus 5 by 3. So these are the values of remaining trigonometric functions. What is important? How to decide the sign of given trigonometric function. Here sec x is 13 by 5. X is in fourth quadrant. You know, here in the fourth quadrant, this to this is fourth quadrant, which is 3 pi by 2 to 2 pi, you know. Now you recall all S, T, C. So here C. So cos and sec are positive. Cos and its reciprocal. These two are positive. Remaining all are negative. Cos positive. Sec positive. So cos x is also positive, which is reciprocal 5 by 13. You know cos, therefore you can write sin x also. You know it is that Pythagorean triplet. This is 5 by 13, so this has to be 12 by 13. Sin square plus cos square is 1. This is 25 by 1 by 169. So this has to be 144 by 169. Now this is plus or minus fourth quadrant, sign negative. So this is negative. I wrote directly, you can use right angle triangle. You know cos, therefore you can write cosec, which is minus 13 by 12 reciprocal. You know cos here, so you can write sec here. What is sec x? 13 by 5. 13 by 5. This is positive. Oh, that's already there. I'm sorry. That's given in the question. Okay. Now 10x. 10x is the ratio of these two. 10x, you just take the ratio of these two. So minus 12 by 5. And you know this, therefore you can write cot x. What is that? Minus 5 by 12. We have this. So these are the values of trigonometric functions. So now next we want the value of sine 765. Now what we do in such question, we do like this. You know, around the unit circle 2 pi is 360 degree, you know this much. So what I'll do, I'll try to find the degree which is very close to 765, and we concentrate at these 4 reference points. Remember here, you know this is 0, this is 90 degree, you know this is 180 degree, this is 270, and this is 360. Now if I do double of this 4 pi, this is 720. So 765 is close to 720. 720 means how many rotations? 1, 360, 2 rotations. So I'll rewrite like this here. This is sine 720 plus how much? 45. Now here 720, it is here only, so it is as good as 0, remember. So this has no meaning. This were discussed. If I start from here, 1 rotation 2 pi, which is 360. If I complete one more rotation, now it becomes 4 pi, which is 720. And then 45 degrees, so it is somewhere in the middle of this. So it is somewhere here, remember, this much, this is the angle. So you can imagine this is like 0, because after 2 rounds you will be here only, and then 45 degrees. So this is just sine 45 degree, and you know sine 45 degree is 1 by root 2. So the value of sine 765 is same as sine 45, and which is 1 by root 2. Question number 7. Cosec minus 1410. Now we already discussed cosec is an odd function, so I'll take minus outside. Cosec 1410 degree. You know this. Cosec of minus x equals to minus cosec x. Recall even and odd function concept. So you have this. Okay, now we think about this. So you can just think over it. 2 pi, you know 360 degree. 4 pi, you know 720 degree. If I double it, let me write 8 pi, which is 1440, right? 1440. Now you can see that it is close to this. This you can imagine, not a big task. So I can rewrite minus cosec. This I can rewrite 1440 minus how much? 30 degree. Is it fine? So just concentrate here again. 360, 720, double of this, that is 1440, which is close to this. When we'll stop this? When we get the measure close to this. So 1440 minus 30 degree. Now 1440, 8 pi, it is here only. After how many rotations? 8 pi means 4 rotations, remember. 4 rotations. Such things, you know, we already discussed. 4 rotations. So if I start from here, let me show here. If I take one rotation, 2 pi. Second rotation, 4 pi. Third rotation, 6 pi. Fourth rotation, 8 pi. And then minus 30 degree. Minus means now after this you will start moving in clockwise direction. So minus 30 degree is here somewhere. This one. Remember. Now this is like 0 because it is here only. You can imagine like 0. So this is minus cosec minus 30 degree. Now again cosec is an odd function, so this is just cosec 30 degree. You know that this is just 2 because sine 30 degree is 1 by 2. Okay. Now question number 3 here. Question number 8 here. 10, 1, 19 pi by 3. Now what we do in such questions, same procedure. This is easier than degree. We again reduce this angle. So we find multiple of 3 which is very close to 19, that is 18, you know. So here 10, 18 pi plus pi by 3. I repeat what I did. I'll find multiple of 3 which is very close to 19, that is 18. So 18 pi plus pi, which is 19. Now this you can rewrite as 10, 18 pi by 3, which is 6 pi plus pi by 3. Right? We have just reduced this in this form, mixed fraction form. 19 pi by 3, I have just reduced in this form. 6 3 the 18 plus 1, so 19 pi by 3. Now you know in trigonometric function 6 pi means how many rotations? 3 rotation. So this look like 0 here. So this is just 10 pi by 3. We are not going to write 0 here, remember, but just for our information, you know it is this point only on the unit circle after 3 rotations. So this is 10 pi by 3. What is 10 pi by 3? Which is root 3. So this way we can get the values of trigonometric functions. Next is sine minus 11 pi by 3. You know sine is an odd function, so minus will come out. 11 pi by 3. If you remember, sine of minus x equals to minus sine x. We have used this odd function. You know this. Okay. Now what we do? We find angle which is very close to 11 and multiple of 3, which is, you can write here 12 pi minus pi by 3. Why I wrote here 12? Because 12 is very close to 11. Multiple is 9 also, but in compared to 9, this 12 is close to 11. So I wrote 12 pi minus pi, which is this. So minus sign outside as it is. Now if I do individual, 4 pi minus pi by 3. You can drop this step. If you can write directly this, that's also fine, remember. What we did, 11 pi by 3, we wrote in this mixed fraction form. 4 3s are 12 minus 1, so pi. Okay. Now you know 4 pi on the unit circle. Look at it, 4 pi. 2 pi, one more rotation, 4 pi. So you'll get this point. And here you have 0. So you can imagine this like 0. So you have minus sine minus pi by 3. Again, you know sine is an odd function. So this is just sine pi by 3. What's sine pi by 3? It is root 3 by 2. Question number 10 here. Cot minus 15 pi by 4. You know that cot is again odd function, so this minus will come out. So minus cot 15 pi by 4. Which concept I have used? Cot is an odd function. Cot of minus x equals to minus cot x. I have used this concept. Now you can do this. Find the multiple of 4 which is close to 15. So which one? 16. So 16 pi minus pi by 4. Do individual division. So this would be 16 minus 4. 4 pi minus pi by 4. Again, what I did, I have reduced this angle into this mixed fraction form. If you want, you can drop this step. Directly you can write this. You just simplify. 4 4s are 16 minus 1, so 15 5. Now 4 pi, on the unit circle, it becomes 0. 2 pi, 4 pi. So this is like 0. So you are left with minus cot minus pi by 4. So minus, again cot will, that minus 1 sign will come out. So this is just cot pi by 4. You know what is cot pi by 4? That is 1. So this way we can compute values of some trigonometric functions for some standard angles. Now here you are given theta equals to 750 degree. The question is, get the quadrant. In which quadrant this angle lies? Get the quadrant. That's a question. You find the quadrant of this angle. You are not asked for value of any trigonometric function. So what we'll do? We reduce this angle. Using which concept? As I explained. 2 pi is 360 degree. 4 pi is nothing but the 720 degrees. So immediately you can realize 720 is close to this. So I can write 720 plus 30 degree. Okay. Now 720 is 4 pi. One rotation 2 pi, one more rotation 4 pi plus 30 degree. So somewhere here. Now this is in general, for example, I'll call the alpha. So you can see that this is like 0. 0 plus something. Which quadrant? Third quadrant. So here theta first quadrant. Theta belongs to first quadrant. Right? So this your answer is first quadrant. Okay. 30 degrees. 720 it is here. We always concentrate at these 4 reference points, remember. 0, pi by 2, pi, 3 pi by 2, then 2 pi, then 5 pi by 2, then 3 pi, then 7 pi by 2, then 4 pi, and so on. So here this angle after 2 rotations, so I can write n equals to 2. This gives you number of rotations. In which directions? Your theta is positive, that means in anti-clockwise direction, like this. If I show it here, start from here, 1 rotation, second rotation, and then 30 degrees, so somewhere here. This you can call this angle. This angle is nothing but the 750 degree, which is same as 30 degree, remember. As an angle they are equal as a trigonometric function. So you can get such values. For example, if I want to get sine 750 degree, it is same as now sine 30 degree. What is sine 30 degree? 1 by 2. If I want to get cos 750 degree, it is same as cos 30 degree. What's cos 30 degree? Root 3 by 2. This way you can answer simple questions. Next one, suppose I want cos 65 pi by 4. What we'll do, as we did earlier, find the multiple of 4 which is close to 65. It's 64. So I can write 64 pi plus pi by 4. This multiple of 4 close to 65. So this is cosine 16 pi plus pi by 4. You can drop this. I have just expressed in this mixed fraction form. Now you see here, 16 pi, it is 0. After how many rotations? 8 rotation. 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, 12 pi, and 16 pi. So here number of rotations n equals to 8. One rotation 2 pi, so 8. This is like 0 after 8 rotations. So this is as good as cos pi by 4. What is cos pi by 4? 1 by root 2. Number of rotations equals to 8, remember. 8 represent number of rotations. In which direction? in anti-clockwise direction because theta is positive here, arc length is positive. One more question, if I see here, next question, let me see. Suppose we are given theta equals to minus 1470 degree. Question is find number of rotations, complete rotations. Remember, number of complete rotations. This is a question. So you know now very well how to do this. Minus sign just indicates that you are moving in clockwise direction, this direction. Okay, so you start with this, you know 2 pi 360 degree, one rotation. 4 pi 720, how many rotations? Two rotation. You double this is 8 pi, which is 1440, right? Now 1440 is close to this, remember. So I can write like this, theta equals to minus 1440 minus 30 degree. Now 30, this minus 30 degree is not important. This is important for number of rotations. Now this is 8 pi. This is nothing but 8 pi. So how many rotations? 4 rotations. So n equals to 4. Number of rotations equals to 4. You cannot have n equals to minus 4, remember. Number of rotations cannot be negative. So complete number of rotations is this. It's like this. If I show here, I'll start from here. One rotation minus 360 degree. One more rotation minus 720 degree. Then again add 364 degree. So here 1, 2, 3 and fourth rotation. So this is nothing but now over here this is minus 1440 here. And then minus 30 degree. So this is minus 30 degree. So somewhere here. This is minus 30 degree. Here you have minus 1440 minus 30 degree. So finally you will get minus 1470 degree. If you want the value, for example, if you want sine minus 1470, it is same as sine of, you know that this is 0. So you are just left with minus 30 degree. Now what about sine? It's an odd function. So minus sign will come out. So minus sine 30 degree. So we'll get the minus 1 by 2. You know sine 30 degree is 1 by 2. So this way we'll get the values of such trigonometric functions. And next question, find n, which is number of rotations, complete rotations, and angle alpha. So first question is here. Let's take theta equals to 750 degree. We did it before few minutes. Again you come to this 2 pi 360 degree, 4 pi 720 degree, 750 is close to this. So you can write 720 degree plus 30 degree. This is called alpha, remember. Now this is 4 pi. So number of rotations, you know n equals to 2. 2 rotations. And alpha is 30 degree. Alpha should be from 0 to 90. This should always fall in the first quadrant. 0 to 90. You can get the values, like if you want sine 750 degree, it is as good as, you know, this is like 0, 4 pi on the unit circle. So this is sine 30 degree. Sine 30 degree, you know, 1 by 2. Next, we have 1125 degree. So you come to this 2 pi 360 degree, one rotation. 4 pi 720 degree, two rotations. If you do 6 pi, that's the sum of these two here, that is 1080. How many rotations? 3 rotations, 1080. So 1080, it's close to this. So I can write 1080 plus how much? 25 degree I need. So it would be plus 45 degree. Now this is 6 pi. So how many rotations? N equals to 3. 3 rotations. And this is like alpha. What is alpha here? 45 degree. It is that extra angle. So after 3 rotations like this, if I start from here in anti-clockwise, 2 pi, 4 pi, 6 pi, and then 45 degree. So it is here, exactly in the middle of which quadrant? First quadrant. So here we can write number of rotations equals to 3 and alpha equals to 45. Suppose if I want to get 10, 11, 5 degree, it is same as, now you know, 11 and 25, it is as good as 45 because this becomes 0. So this is 10, 45 degree. What is 10, 45? You know it is 1. Right? If I want, for example, sine 1125 degree, it is as good as sine 45 degree. What is sine 40? Because this same as this. After how many rotations? 3 rotations. So this is 1 by root 2. Right? So this way we can find number of rotation. There are some other ways also to get the rotations. What you can do is, you divide, for example, if you want the number of rotations, divide 750, you know one rotation is 360 by 360 degree, and you take its box value. Box value means what? Only positive integer. You will get here 2 point something. And what's the box value of box? You know, least integer greater than or equal to that number, integer part function. So answer will be 2. So here total number of rotations is 2. Here also you can do, you can find number of rotations, n equals to 1125 divided by 360. You can see that you will get the 3 point something. And what's the box value of this? Box, you know, first integer from left side, so you'll get the 3 only. Box function, if you remember. So you'll get the 3. This is another way to get the number of rotations.